All right, good morning, guys. Hope you guys are doing okay. Today we're going to discuss herbal preparations and different types of formulas you can use in herbal medicine. So what we're going to do is we're going to begin with discussing some of the abbreviations used in herbal medicine, some of the things you might see in a book or that you can write on a prescription. We're also going to talk about the different types of ways you can administer herbs, whether that's in a let's say in a tea or in an alcohol extract called a tincture, or how to apply them topically. Then we'll discuss some ways that you can take them internally and also apply them externally to your skin. Okay, there's a number of little goals you can read there, and basically the main thing we want to do is kind of give the pros and cons of each of the different types of formulas that you can use in practice, and also figure out what's the best sort of type of extraction to use based on the herb that you're selecting, and also based on the costs involved with it as well. So to begin with, I just want to talk about some of the abbreviations you may see in certain herbal textbooks. Now, I find this is common in some of the Chinese texts. Some of the books I have from Germany use these abbreviations. You may or may not see it in some of the books, but just to give you a basic idea, what I've created is a table here, where on the left-hand side is the abbreviation that you'll see. I've explained the Latin term in the center with the brackets around it referring to the English term, and then an example of a particular herb that might be like this. Okay, so to begin with, an abbreviation BAC refers to Bacchae, which is berries, and so you might have that with a notation where it may be BAC blueberries, maybe the particular herb written about. Or bulbs, for example, you can have garlic and onions come in bulbs, and so the Latin term for that is bulbous, and the English term is just like the abbreviation bulb. Other ones, for example, are cortex, and so cortex refers to the outer layer, and so certain plants, whether you're using the bark like cinnamon and oak, it may be, for example, oak court or court oak would refer to the outer bark rather than, let's say, in the leaves or whatever other part of the plant it might be. The flowers is referred to as the flor, or flores in Latin, so you might use that in marigold, like calendula flowers, chamomile flowers. Other things use the leaf, so fol or folium refers to the leaf, and so you may use that in peppermint. There's other hawthorn leaf would be another example. Sometimes they may just use only the fruit. They could use a flower, they could use a leaf. So fruct refers to the fruit, so fructus is the Latin term for fruit. That refers to hawthorn. And then if you're using the entire plant, which you sometimes will see with peppermint, which may be just the leaf, or you may use the entire plant, which could include the roots and also the flowers, the stem, then that refers to as herba, like the whole herb. So wormwood, thyme might be examples where you'd use that. There are some herbs that are technically not really a herb, but rather a lichen. So there's one in particular called usnea, or old man's beard, and that's a lichen that you'd use. Another type of root you might, or there's two types of roots you might use. One is a classic root, and the Latin term for that is radix, or the abbreviation is rad. So ginseng, licorice, astragalus. So it may be, for example, you'll see written down rad ginseng or ginseng rad would refer to the root of it, because in this case you don't want to use the leaves and the stem and the flowers, you only want to use the root. Now, a specialized type of root, which is a rhizome, what distinguishes that from a normal type of root is if you take a rhizome and you break it in half and plant both pieces of the rhizome, you'll have two separate plants coming up from it. And you can't do that with a ginseng root or an astragalus root. So a rhizome, it grows under the ground like a root does, tends to go horizontal to the ground, and then new plants can come up from it. So The classic rhizome plants would be things like ginger and turmeric. You can buy these at the grocery store. So some people will call them roots, but technically it's a rhizome. The next thing are the seeds. So semen, semina is a Latin term, and a lot of the culinary spices we use, like fennel, anise, coriander, cumin, and seeds that you might eat for protein and for fats would be like flaxseed or chia seeds. They would all have the abbreviation of SEM dot. Okay. Now the final one is strobili, and this refers to the cone. Now these are like the pine cones, and other coniferous trees produce cones. It's kind of a specialized type of flower. The only herb that I can think of that has these types of cones that you use in practice would be hops. So when they make beer, or you make a tincture or tea or whatever it may be from the hops, it's the actual cone that you're using, or the strobili. Okay. So you can see there's some examples of how it might be written in a book. There's cranberry, there's onions, there's Cotinopsis. Here's a rhizome of turmeric on the left. Like I said, you break that in half and you can plant it in the ground. That's what hops looks like in the middle, those little soft cones that it has, unlike a pine cone, which is hard. Here's like the fruit from a cayenne plant. So those are some examples of how they may be labeled. There's chamomile flower, peppermint leaf, and then there's a lichen on the right hand side from old man's beard, or usnea. So those are some Latin abbreviations for the different parts of the plant. Now in herbal medicine, one of the things that's important is discussing measurements. Now one of the tricky things with measurements is it's not always consistent depending on what you're using. For example, when you're referring to teaspoons, most teaspoons are usually considered to be 5 mils, but there are some teaspoons that are only 4 mils. So a teaspoon could be 4 or 5 mils. That's a 20% difference, and that's, significant. So you can see that herbal medicine isn't an exact science. Often when I recommend people take a tincture, it's usually 1 teaspoon 3 times a day. So depending on what type of teaspoon they have, it could vary by 20%. And that's worth remembering there. Now another thing is, a tablespoon is more precise. I think everyone can agree that's 15 mils, generally speaking. Okay. And then finally, when it comes to drops, the volume of drop depends on what you're taking the drop of. So if you're using 100% water, you have hydrogen bonding interacting with the oxygen bonds, and that kind of creates like a little force that keeps the water droplets together. So you'll actually get a larger drop of water than you would if you're trying to take a drop of alcohol, because of the polarity of that solvent. It acts as like a little magnet, sticks together, so it allows it to create bigger drops. If you added soap to the water, it's going to break the surface tension, and then your drops will be smaller. So herbs that are rich in saponins, the drops may be slightly smaller than other tinctures. Also, the higher alcohol content you go up, the smaller the drops will be, because there's less water and less of these hydrogen bonds working. So there's a little bit of confusion. Some textbooks, herbal textbooks, will discuss using drop doses. So instead of saying half a teaspoon 3 times a day, they may say something like 30 drops 3 times a day, or 40 drops per day. And appreciate that that might be fine to use, but you will get some variation. So if they're recommending a particular tincture and it's 40% alcohol, and you get a tincture that happens to be 60% alcohol, the dose that the person's getting is going to be different. 1, because the drops will be different, and 2, also you've changed the solvents, so certain things will be dissolved differently. In the end, it probably doesn't matter that much. Herbal medicine's pretty forgiving with, I would say, all the herbs that you're going to be, or almost all the herbs you're using in practice. There's a few herbs that we don't use in practice you will learn about that are certainly more dangerous, and drops, if you prescribed it and someone got twice as many drops, that could be fatal if it were a herb like aconite or belladonna. Probably not belladonna, but even then they're pretty forgiving, okay? So when it comes to droplets, when you're administering, appreciate, like I did a little experiment just to see. I took a mill and I put drops of water into it. And I basically found that I could get 20 drops of water into 1 ml volume. Now when I used tincture, it seemed to vary quite a bit. So when I did, let's say, a 40% alcohol extract, which a lot of the tinctures are in, and figured out how much would go into basically half a teaspoon, 2.5 mils, I found that I got about 40 drops. So I almost got twice as many drops in an alcohol, like a 40% alcohol solution, compared to just using water. And the reason why I did a larger volume was I could get a better average over that. So the take home is water drops are bigger than alcohol drops, okay? Now another thing we're going to discuss is how you write a little prescription for herbs. So this is not a good way to communicate to your patients because they won't understand these abbreviations, but for your own charts when you're writing up your soaps and your prescriptions that you're recommending to your patients, or if you're communicating, let's say, to someone working in a compounding room, then you could use these abbreviations. On the exam, I may have I may have maximum 1 question on this, okay? So if you don't want to learn it, you don't have to learn it. You just lose 1 in whatever, 65 or 70 marks, okay? Or you take a guess. I'm not going to deliberately try to make it tricky, but what you can do is look on the left-hand side or the abbreviation, and it explains sort of the Latin and the English terms on the right. And for example, here you'd have, if you recommended 1 teaspoon AC of the herb, that would be 1 teaspoon before meals. Or if you said, 1 tablespoon CC means 1 tablespoon with food, okay? If you want to take it on an empty stomach, it would be, let's say, 5 drops or whatever it may be. IC is between meals. So that would be an example. When you're talking about how many times a day to do it, QD means once a day. B, like a bicycle, means 2 or twice a day. Tricycle. TID means 3 times a day. And then QID, which is not to be confused with the QD, is 4 times a day. So QD is 1 time a day. QID is 4 times a day. There's a few other notations, like if you're making up your tincture, you say QS is add enough, or QSAD means add enough water to make. So just try to translate these. Take 1 tablespoon PO, QD, SC, and then on an exam I give A. Does this mean take 1 teaspoon per rectum 4 times a day, or is it 1 tablespoon by mouth 1 time a day with meals, etc., etc., okay? Not trying to be too tricky there. So most of the time in practice, the herbs that I get are ones that I buy from a herbal manufacturer, or I will buy the herbs in bulk, and I'll sell teas to patients that we may compound ourselves. We have tinctures that we get that we'll compound ourselves. Occasionally I'll gather wild herbs, but I don't do this a lot, mainly because I don't have enough time to do this. And but if you really wanted to, you could easily gather a lot of your own herbs and make up your own tinctures, and there would be nothing wrong with doing that. So, and I've certainly done that in the past. It would save you money in the beginning, maybe when you're private practice where you have more time than money. You could consider doing this. Now, talking about gathering and storing herbs, there's lots of herbs that grow wild that you can easily access, or you can grow certain ones yourself. When you're looking at, there are two main types of sources of plants. There's cultivated plants, which means that it's farmed or it's grown in a garden. And this is probably a better way to get a lot of things. Like, for example, ginseng is not a herb that you want to necessarily wildcraft. You want to have it grown because it's an endangered plant. So there may be some exceptions to this. I would say there's no shortage of dandelion. In fact, probably if you're getting rid of some dandelion plants, you're doing the world some good. Dandelions propagate very, very easily. And you can find them pretty much anywhere around the world, literally. Chicory is another one. I often will gather, I've gathered hawthorn in the past. I've gathered elderberry, certain herbs for burdock I've gathered. So there's a bunch of things that I can get that grow wild around here. Black walnut does, etc., etc. So I've also grown certain herbs and use those as well. So I've grown ginseng and echinacea and a few other things. So cultivated means grown in the garden. Wild crafted basically means you're just walking out in the field or a woods or wherever it is and you're just picking them. So if you're doing that, there's a couple little tips you should be aware of. You want to make sure you choose where there's a healthy plant community. Certain plants, when you pick one, when you harvest the plant, you've basically killed the plant and there's no opportunity for a new plant to come up. So in the case of ginseng, it might take, let's say, 4 years or more for the plant to mature. Once you pick it, it's gone. And and it doesn't send out a lot of seeds, and it tends to grow with some difficulty, and it's very particular. And because of over-harvesting in the past, it's virtually impossible to find it in the wild. It does exist in a few places in Ontario, but it's pretty hard to find it. Just as an aside, most of the Canadian ginseng now is being grown in the old tobacco fields in southern Ontario because people are smoking less and ginseng's becoming more popular around the world, especially in Asia, where it's always been popular. And so they've converted the tobacco fields to ginseng, which is kind of cool because one thing causes cancer, and now the ginseng actually helps with people who do have cancer as well as other things. Another idea when you're wildcrafting herbs is you might consider rotating the locations where you gather the herbs. So you may not want to go and, depending on what part of the plant you're getting, you may not want to take it from the exact same spot. You may want to go to a different tree. Now there's certain things that won't matter if you're gathering the fruit or the berries. It's probably not a big deal, but if you're gathering roots, and they're hard to find, you might want to move around a bit. Another thing that's worth remembering, whether you're doing wildcrafted or cultivated, is that there's the right time of year to harvest the plant. So, and also the right time of the day to harvest certain plants. So, for example, there's research that shows that if you want the essential oils in lavender or peppermint, then pick it first thing in the morning because the plant's been manufacturing these essential oils all day long or all night long, and they'll be concentrated in the plant in the morning. And let's say if it's 40 or 30 degrees outside, those volatile oils are going to escape into the atmosphere throughout the day, and so probably in the evening there's going to be lower amounts in the plant than there would be in the morning. There are other plants that you need to harvest them when you have the highest amount of phytochemicals in it. For example, there are certain roots that you only want to grab 1-year-old roots because they only live for 2 years, and they concentrate all the good stuff after 1 year, and they kind of use up all the good stuff by the second year. So people, for example, with burdock recommend first-year roots, but not second-year roots. Also, other herbs like ginseng, the longer it's in the ground, the better it is. So you don't want to harvest it until it's at least 4 years old, ideally 7 or 8 years old. Also, harvesting it in the fall for certain plants is better than in the spring. So lots of different things. And again, as I mentioned, avoid the threatened and endangered plants. Now, one thing that you'll notice is that if you go to the grocery store or in your garden, you harvest some fresh spices like basil, it's different than the dried basil in a few different ways. Now, it's possible that you may have higher amounts of certain constituents in a fresh herb than you might have in dry herbs. But for the most part, a lot of the herbs that are used in herbal medicine, it's often they're using the dried extracts, dried herbs that have been preserved with alcohol or made into teas. And so you can make it with fresh herbs, and there may be some differences, but I don't know if there's any major advantage to it. And I know there's one herbal manufacturer who uses a lot of fresh herbs, and they believe that the energy of the plant is greater in a fresh herb than in a dry herb. But there's no reason that I can think of phytochemically why one would be superior. It could just be a marketing thing. Now, certainly I like the taste of fresh basil over dried basil, but they both have the phytochemicals, assuming that your dry herb hasn't been sitting in your kitchen for 5 years in an open jar. Both fresh and dried leaves will have essential oils and other things in it. Now, one of the big differences between fresh herbs and dry herbs is the fact that there's more water in a fresh herb. That seems obvious, but appreciate the leaves of some things may have 90% water in it. And when you have a dried leaf, it may have, probably won't be zero, but maybe less than 10%. And so that means by weight, you're going to have less of the actual herb in it when you use it to make something, because a lot of it's water and it's giving you kind of a false weight for how much of the actual active ingredients are in there. So leaves are about 90% water, or can be up to that. Roots, when it's fresh, could be as much as 50%. Obviously, I'm kind of ballparking these numbers. So the take home with this is, if I'm making a tincture with fresh herbs and I'm using, let's say, 4 parts of alcohol to 1 part herb, but I'm using fresh leaves that are 90% by weight water, then it's going to mess up all my concentrations and ratios and required measurements to get the desired therapeutic amount in it. So I'm actually going to have to use either a higher alcohol concentration to compensate for that added water in it, or I may have to use more herbs to get the right amount of phytochemicals. Okay? So generally speaking, I prefer using dried herbs. Now, if you're going to dry herbs yourself, the most important thing is to have good ventilation. And I've made the mistake of gathering a bunch of herbs and not drying it in the best spot, and there was poor ventilation, and it didn't dry quick enough, and then mold started to grow on it after a couple days, and I had to throw it all away. So you must have really good ventilation. Another thing that you want to do is ensure that the material that you're gathering is spread out and not overlapping, so that there isn't pockets where water can get trapped in there. It's important to make sure there's heat, because heat's good for allowing for evaporation. So if you're trying to basically dry something in your basement where it's cold and damp, it's not a good spot. It should be somewhere where it's warm with lots of airflow going on, and also a relatively low humidity as well. And so another thing that's important is to have it away from sunlight. Now, the two things that damage chemicals in general is high temperature, air, UV light. So if you want something to last a long time, you need to remove UV light, air, temperature. Okay? A good place, if you are doing just a small batch of herbs, one of the good places you can do it at home is You could get like a screen that's used in Windows, for example, and lay your herbs out on that. And let's say if you've gathered some roots like burdock root, you could try to dry them in whole intact. I'd recommend cutting them into small pieces as possible. The smaller the pieces, the greater the surface area, the faster it's going to dry. It's also easier to make decoctions and teas with it, if that's what you're going to do, and to do make tinctures with it as well. So lay out the herbs on the screen, and then what I would do is just prop it up with maybe just some kind of little block or something at the corners of it, so there's lots of space underneath it, and put it on top of the fridge. Now what's nice about the fridge is there's a fan that generates heat and air, and it kind of pushes it up behind the fridge, and so you'll naturally have just a little bit of heat and airflow above the fridge. That will help to dry those herbs better. Or you hang them over top of the fridge as well from the ceiling. That's another thing you can do as well. You don't have to lay them flat on a screen. You can just hang, like you've gathered a bushel of basil, for example. You could just string it up together and hang it up, and just make sure that it's not packed too tight. So those are some examples of how to get your fresh herbs and how to dry them. Okay. Now, when it comes to storing herbs, as I mentioned before, heat, air, UV light. So you want to put it in airtight bags or jars. You want to ensure it's dry. So often this is why you'll get desiccants in with like a pill bottle, because it keeps it nice and dry. If you plan on using it relatively quickly, it's probably not as important. But if you're trying to store herbal material and you're in a really highly humid environment, it's not the best place. So you may want to have an air conditioner that takes the humidity out as well. With regards to the UV light, ways that you can combat that is storing it in a brown bottle if you're making tincture. So if you think about beer, one of the components in beer, the hops, has a compound that's very sensitive to UV light, and when it's exposed to UV light, it'll make the beer taste skunky. So skunky beer is when it goes bad, and that's because of UV light. And that's why almost every single beer is bottled in a brown bottle, with the exception of Corona, which I find often goes skunky. So UV light, you want to use bottles that are brown or opaque. And if you're drying the herbs, a little bit of UV light's not going to destroy it. Again, it's going to be dependent on how long it's left in the light. But if it's for days, probably not the end of the world. But if it's for weeks, not great. And again, temperature is important for storing it to keep it cool. So you want it warm when you're drying it for a few days, and then when you're storing it long term, the cooler it is, the longer it's going to last for. So the question is how long do herbs last for? The shelf life is probably going to vary significantly based on the type of part you're using, how it's prepared. Let's say if you have a powder, it's got a greater surface area, so it will be more susceptible to oxidation and moisture, and will need to be stored like in a vacuum sealed sort of thing with maybe desiccant in order to ensure its quality sort of lasts as long as possible. If you're using, if you look at like a root that's a big chunky piece of, let's say, ginseng, and it's been dried out, that's what you typically see in places like Chinatown. They have big barrels of ginseng root, and it's just sort of left to the elements. But I suspect that because it's such a large root with a relatively small surface area, because it's not ground up into powder, it's pretty stable that way. If you were to have big barrels of just ginseng powder, just kind of like a bulk food store, just people could walk by and just access, and it was exposed to humidity and UV light, I think that would be a bad thing for it. So leaves and flowers, nobody really knows exactly. I would say if it's in a tea form and it's sealed pretty good, about a year. Like if you think about the spices in your in your kitchen, you will often, I know I've got some turmeric that's at least 3 years old kicking around in there, and I know there's some marjoram, which I don't use very often, in there, and it still tastes good. It may lose some of its volatility, or the volatile oils will evaporate off a little bit, but the more intact they are, the longer they'll last for. So leaves and flowers, maybe a year or two. So if you have teas in your clinic, I would maybe change them after a couple of years. 1 year should be good. Root, barks, and seeds, the more intact they are, the longer they're going to last for as well. Also, it's going to depend on your humidity and how airtight and everything else. But generally, some people might say 3 to 5 years. And again, these are still estimates or guesstimates. Tinctures, they've done studies on tinctures that are over 100 years old, and they still find that it contains the active ingredients for a few of the herbs that they were studying. So tincture is probably a little bit like, it's going to be like, wine's good for decades, but sometimes it'll go moldy or go bad. Tinctures won't go moldy because 40% alcohol is what a lot of them are at, contain. Nothing's going to grow in that. So it's more likely that over time, certain compounds will just start to precipitate out of solution. Kind of like when you have an old bottle of wine, like the anthocyanidins, you'll see like that sediment in the bottom of the wine bottle. That would be some of the polyphenols that are just slowly over time falling out of solution or reacting with one another and maybe forming polymers that aren't soluble anymore. So you might lose some potency over time. Now we do know that, for example, St. John's wort, one of the active compounds in that is something called hyperforin, and it's the main antidepressant compound. The problem is with hyperforin is it's not very stable in an aqueous solution. So if you store it in a tincture, it will degrade relatively quickly in an alcohol tincture compared to if it was in a capsule or a powder or a pill. So you can still get St. John's wort tincture, but it's unlikely to have as much of an antidepressant effect as if you were to use a capsule or some other form. Okay. Now that being said, St. John's wort tincture has other phytochemicals. You can still use it for wound healing and antivirals and a few other things, but maybe not for the antidepressant. Mind you, the placebo effect for antidepressants is about 40%, so there's still a good chance you're going to get some success, but it's probably going to be more placebo than an antidepressant effect. Now, one thing I want to discuss as well is have you understand a little bit about the chemistry of doing extractions. Now, I worked as a synthetic chemist for a couple years. I had a research project, and I basically worked in a lab and made drugs for a year. It was pretty fun. And depending on what the chemical is that you're trying to extract, you have to use different solvents to extract it. So polar basically means water soluble. Non-polar means fat soluble. Okay? And depending on what you're trying to extract, you have to ensure you use the right solvent. So some people are like, is alcohol a good solvent? My answer is, well, it depends. Depends on what you're trying to extract. Is water a good solvent? Yeah, it depends on what you're trying to extract. Is oil a good solvent? It depends. If you're trying to isolate something that's a polar compound, then it's fantastic to use water. If you're trying to dissolve a resin that's made of non-polar terpenoids, water is not the best solvent for it. Okay? So how well that desired compound dissolves is going to depend on the polarity of it and the polarity of the solvent. Also, the higher the temperature, the better it is as a solvent. Think about if you might be able to add a teaspoon of sugar to a glass of water, while you might be able to add a couple tablespoons of sugar to a glass of hot water. The pressure, atmospheric pressure, can influence what dissolves in it. So essential oils, if you took some kind of solution that contained peppermint oil in it, and then you sucked out all the air with a vacuum, the water and those essential oils will start to evaporate off at a very low temperature. So pressure can influence that. The solubility of the herbal product itself will depend on how much surface area it is. So if you have a big chunk of ginger and you just sort of plop it into a bowl of tincture, it may take months for it to extract all those good things, because it's going to be hard for the alcohol to permeate it and penetrate it. Well, if you just took ground ginger powder and threw it into a bowl and added the same amount of alcohol, you'd probably extract it instantaneously, and it would be a good way to do it. The acidity of your solvent can sometimes affect the solubility of certain compounds. Now, the only real compounds that will affect is, for example, the alkaloids. Alkaloids are nitrogen-containing compounds, and so when you make the solution more acidic by adding acid to it, you protonate that nitrogen, and now it becomes NH+, and that plus means it's now water soluble. So that allows you to, sometimes the old tinctures, they used to add a little bit of like 5% acetic acid, which is vinegar, to a tincture, if you're trying to use it for like golden seal, because golden seal contains the isoquinoline alkaloids, and by adding a little vinegar to it, you can actually get more of the berberine out without having to use more of the herb, which is kind of cool. Other examples of that, for example, in chemistry, when people do, if you wanted to, I'm going to give you a real world example. When people try to get cocaine from the coca leaf, the way they do it is they take the coca leaf, they dissolve in water, they add acid to it to protonate all the cocaine molecules that are alkaloids, and then they filter it all off, the remaining solution. And then what they end up doing is they change the acidity of it, so they take it from being an acid and they add like baking soda and they alkalinize it, so the pH basically goes up and becomes less acidic. And then as the acidity goes down, the protons on the nitrogens that are removed, it loses its charge, and then all the alkaloids precipitate out of solution, and then they can be easily be obtained by just filtering it with a simple, like a coffee filter sort of thing. And then that powder that's collected on the filter is going to be that alkaloid. And so this can be done on all sorts of different alkaloids. I've done that, not with cocaine, never, and I never would, but I've done it on other alkaloids when working as a chemist. So when it comes to figuring out how polar the compound is that you want to extract, there's not an easy way to do this that's exact, okay? But there's a really easy way to do it just by eyeballing it. And what makes something polar is how many oxygens are on it. Nitrogens also, and sulfurs to some degree, but the oxygens is the big thing. So if there's lots of oxygens compared to the carbons, that will be water soluble. If there are very few oxygen and lots of carbons, then that's nonpolar. So polar means oxygen, nonpolar means carbon. Okay? So there's a few solvents I'm going to give you an example. Water is one that we use quite a bit. Glycerol I don't use very often. Ethanol I use all the time when I'm making tinctures, and it's kind of both a polar and a non-polar. And then you can use other ones like vegetable oils, which are non-polar solvents. So I made these this picture up for you. At the top we have polar, meaning water, okay? So water has 0 carbons in it, so that's the most polar thing that you can get. Now you go down, glycerol is a compound. Remember, this is the backbone for making triglycerides, okay? That's what you find in fat. There is 1 oxygen for 1 carbon. So there's a 1-to-1 ratio of oxygen to carbon. So it's a little bit less non-polar than water is, but it's still pretty polar, okay? Ethanol has 2 carbons for 1 oxygen. And so that's so the reason why alcohol is so great is you're able to dissolve water-soluble components, and you can get some of the fat-soluble stuff. You will get some of the compounds like the terpenoids, some of the phenolic compounds like going into ethanol. And so that's a good solvent. Now propanol, which is rubbing alcohol, it has 1 extra carbon than ethanol does. This will kill you if you drink it, but it's a great solvent for some things, and I'll show you another picture. So everything else here is edible, except for, well, pinene you don't want too much of, propanol you don't want. So just because I'm listing here doesn't mean you should go and make tinctures out of rubbing alcohol, okay? Oleic acid, which olive oil contains, usually it's oleic acid bound to a glycerol backbone. The basic ratio of a free fatty acid like oleic acid is about 9 carbons to 1 oxygen, because there's 18 carbons and 2 oxygens. Now, the polarity of the OH here is different than the polarity here, but they're still polar, okay? So this isn't quite the same as if it had like 2 OH groups, because this is like an acid, a carboxylic acid on there, but anyways, I'm still giving you a ballpark idea. And then finally, pinene, which is what's in turpentine, this is basically has no oxygens. It's all carbon. And so as a result, this would be a great non-polar solvent. So if you're using, trying to dissolve grease off your hands, water won't work, but turpentine will, okay? So this is just a good way of understanding it. So if you want to dissolve something, you got to figure out how polar it is. So, like dissolves like. So polar solvents dissolve polar compounds. Non-polar solvents dissolve non-polar compounds. Semi-polar solvents dissolve semi-polar compounds. So going back up here, the ethanol, the propanol, those are semi-polar solvents. You know, I would say olive oil and turpentine are non-polar, and water, glycerol's kind of semi, but it's pretty polar. So to give you an example, carbohydrates like glucose, you count the ratio of oxygen to carbons, you got about a 1-to-1 ratio of oxygens to carbons. So, glycerol and sugars are remarkably similar in a lot of ways. So sugars dissolve great in water. They will dissolve in alcohol as well. They won't dissolve very well in fat though, okay? And then you look at something like a flavonoid here. This is ballpark a 2-to-1 ratio of carbons to oxygens. This is a great solvent for alcohol. Is a great solvent for flavonoids. No surprise when you look at like red wine. That nice red pigment is the anthocyanins, a type of flavonoid, and they dissolve great in there. Even for example, like if you're looking at grape juice, it contains flavonoids because it is water soluble. Also, a lot of those flavonoids may exist as glycosides. So if you added a sugar onto the flavonoid, you'll make it more polar as well. And so that's why things like flavonoids are somewhat water soluble, and some of them exist as glycosides as well. Now remember, turmeric contains a curcuminoid compound called curcumin. This compound here, if you quickly add up oxygens to carbons, you're looking at about a 3-to-1 ratio. So it's not going to dissolve great in water. It's also not going to dissolve great in oil. So it's going to be somewhere in between that. A little bit will dissolve in alcohol for sure. Okay. Generally speaking, sesquiterpene lactones, if you remember, 15 carbons. This one has 4 oxygens on there. Or is there more than that? 1, 2, 3, 4, and 15 carbons. And so there's a higher ratio of carbons to oxygens on this compound here than there is on this one. So it's going to still dissolve in alcohol, but it's not the best thing for it. You will get some of these possibly dissolving in the nonpolar solvents as well. And then finally, look at something like a tetraterpene, like lycopene, contains 0 oxygens. It will not dissolve very well in water. Actually, it won't dissolve at all in water. It would do very well dissolving in something like olive oil. Okay? Or turpentine, but turpentine, you don't want to make some kind of infused turpentine for your bread or your salad. So you have to think about whether it's edible or not. So here's an example where I took turmeric powder, just threw it, excuse me, saturated test tube out of the water, and you can see the water, the yellow is an indication of how much curcumin's in there because it's a yellow compound. So I did this to visualize how much curcumin you can see is dissolving in it. So a little bit in the water because there's, if you look at the number of oxygens, there are oxygens there. Alcohol does better in because, again, this is a 2-to-1 ratio solvent and this is a 3-to-1 ratio molecule. And just for fun, I used rubbing alcohol because I knew that that would be the best solvent for it, looking at the structure, because this has the same, more or less, ratio of carbons to oxygens, and that's that 3-to-1 ratio. And so this has the best absorption of all these guys, okay? Now I also tried using turpentine, and turpentine was ever so faint. Didn't really work very well either. And olive oil didn't work that great. So appreciate it. It's not a polar and it's not a non-polar compound. It's a semi-polar compound. So if you could make tinctures out of rubbing alcohol, that would be the best solvent for you, but you can't. So don't do that, your patient, or you will get sick and possibly die, okay? So there you go. Okay, we're just going to take a little break here and then come back in a second.